Hello everyone, welcome to Equal To, and this is episode 26 of a Polynomials playlist. And in this video again we are going to see a couple of questions from exercise 2.4. Okay, we are starting with exercise question 9, which is to verify this thing called x cube plus y cube equal to x plus y into x squared minus xy plus y squared. Okay, so you have to verify this LHS equal to RHS. Okay, now let us first start by thinking which are the identities that we have seen x cube and y cube terms in. Okay, one identity that comes at the top of your mind is x plus y the whole cube, right? So in the identity x plus y the whole cube, obviously there are terms x cube and y cube. So that is where we are going to start this question with. So x plus y the whole cube can be written as x cube plus y cube plus 3xy into x plus y, right? This is the x plus y the whole cube identity. Okay, now we need x cube and y cube alone, right? So what we are going to do is we are going to have this x cube and y cube at this end, and we are going to move all the other terms to the other side. Okay, so it's going to be x plus y the whole cube minus 3xy into x plus y, which is equal to x cube plus y cube. Okay, now you can also tell this as subtracting minus 3xy into x plus y in both the sides, and that is technically accurate in mathematics. Okay, bringing one term to the other side, it essentially means that you are subtracting that term from both sides. Okay, now this is what we have now. Now if you look at the RHS, you can see this term is entirely x plus y the whole cube, and we have x plus y into minus 3xy here. So in these two terms we have x plus y as a common factor, right? So you can take this x plus y as a common factor outside, and that leaves you with x plus y the whole squared minus 3xy. Okay, I hope you got this. This is very simple, very small steps that we are doing. So which is equal to x cube plus y cube. Okay, now from these two terms you have just taken x plus y as a common factor. Okay, in the next step, let this x plus y be there as such. We are going to expand this x plus y the whole squared. So that is going to be x squared plus 2xy plus y squared minus 3xy. Okay, which is equal to x cube plus y cube. Now we have minus 3xy here and 2xy here. Okay, so we can further simplify them, right? So x plus y into x squared minus xy plus y squared, which is equal to x cube plus y cube. Okay, now that is the statement that we are supposed to verify, and that has come out right. Okay, let me just adjust this a bit. Okay, so that is the statement that we are supposed to verify, and we have verified it successfully. It's quite easy. You just start with this identity x plus y the whole cube, and you just move in the direction of the question. Okay, we need x cube plus y cube, so we have that on one side, and we bring all the other terms to the other side, and then we just try to factorize it, and that gives you the answer. Okay, now this is one more identity that you can remember. Okay, this is one more identity. Okay, have this in your mind. We'll be using this in the next question. Okay, now moving to the next subdivision of this very same question, we need to verify if x cube minus y cube equals to x minus y into x squared plus xy plus y squared. Now the steps are going to be very similar to the previous subdivision. Okay, where have we seen x cube and minus y cube? In x minus y the whole cube formula, right? So x minus y the whole cube is equal to x cube minus y cube minus 3xy into x minus y, right? This is what we know, and we need x cube minus y cube on one side. So we are bringing all the other terms to the other side. So we have x minus y the whole cube plus 3xy into x minus y. It becomes plus because it has come to the other side, right? Or in other terms, you have added 3xy into x minus y on both sides, okay? And that is equal to x cube minus y cube, okay? Now on the RHS, you can see that x minus y is a common factor on both these terms. So I am going to take that out at a common factor. So we have taken x minus y as a common factor outside. So that leaves you with x minus y the whole squared plus 3xy. Okay, and that is equal to x cube minus y cube. Now we have x minus y the whole squared here. So you can further expand it. So x minus y into, here we have x minus y the whole squared, right? So x squared minus 2xy plus y squared plus 3xy is equal to x cube minus y cube. Okay, in the next step, you are going to cancel these out. So x minus y into x squared plus xy. How did it become plus xy? We have minus 2xy here and we have plus 3xy here. So that on adding becomes plus xy plus y squared, which is equal to x cube minus y cube. Okay, I'm just going to pull these things down a bit, and that is the answer to this question. You have verified that x minus y into x squared plus xy plus y squared is equal to x cube minus y cube. Now this is another identity as well. Okay, these are two identities that you have to keep in your mind. So x cube plus y cube equal to x plus y into x squared minus xy plus y squared, and x cube minus y cube is equal to x minus y into x squared plus xy plus y squared. Okay, so that is with this question. Moving on to the next question. This question is a application of the previous question's identities. Okay, we have learned two identities, right? This question is the straight up application of those identities. Okay, factorize each of the following, and this, as you can see, obviously is of the form x cube plus y cube, right? So you can straight away proceed with that. So 27y cube plus 125z cube. Now before applying the identity, we can first write this in the proper term. Okay, so what do I mean by that? 27 is basically 3 cube, right? So this can be written as 3y the whole cube plus 125 is 5 cube, right? So it can be written as 5z the whole cube. Okay, now it is of the form x cube plus y cube, right? So let me just write the identity here. So x cube plus y cube is equal to x plus y into x squared minus xy plus y squared, right? This is the identity. Okay, let me just have it inside a box. Okay, this is the identity and we are going to use this. We are going to straight up apply this. So x is equal to 3y in this case and y is equal to 5z in this case. Okay, on applying that, you get, like LHS is already there, right? 3y the whole cube plus 5z the whole cube is just going to apply it on the RHS. So that is going to be 3y plus 5z. So that is our x plus y term into x squared, right? So 3y the whole squared minus xy. So that is going to be 3y into 5z plus y cube, sorry, y squared, right? So 5z the whole squared. Okay, so that is your RHS. Now this can be further simplified, right? We have the square and multiplication, so that can be done further. So 3y plus 5z into 3y the whole squared is 9y squared, and it's minus 15yz plus 25z squared. Okay, so this is the factorized form and this is your answer. Okay, we have just applied that identity straight up and you have got your answer in the factorized form. Moving to the next subdivision. Now this is very similar as well, but instead of x cube plus y cube identity, you are going to use x cube minus y cube identity. Now before that, you first have to represent it in the form of x cube and y cube, right? So 64 is 4 cube, right? So it can be written as 4m the whole cube. 4 times 4 is 16 and 16 times 4 is 64, so it's right. Okay, and 343 is it 7 cube or 8? 7 times 7 is 49 and 7 times 9 is 63. We have a 6 here. 7 times 4 is 28. 28 plus 6 is 34. So 343 is 7 cube. Okay, so 7n the whole cube. Okay, so 4m the whole cube minus 7m the whole cube, and now you can use the identity x cube minus y cube, which is equal to x minus y into x squared plus xy plus y squared. Okay, so that is the identity. Now we are just going to apply this. In this case, x is equal to 4m and y is equal to 7n. And applying this identity, x minus y, right? So 4m minus 7n into multiplied by x squared here is going to be 4m the whole squared plus 4m into 7n plus 7n the whole squared. Okay, we can further simplify it. So it's 4m minus 7n multiplied by 4m the whole squared becomes 16m squared plus 7 times 4 is 28. So 28mn plus 7 squared is 49. So 49n squared. Okay, and that is the factorized form. We have factorized both these polynomials just by using the identity x cube plus y cube and x cube minus y cube, which we have derived or proved in the previous question. Okay, so that is all for this video. We have solved 2 questions. So we have solved 10 questions so far in this episode, like in this exercise. I hope you have watched the previous videos also. If you haven't, go and check them out. And if you have any doubts in the questions that we have discussed in this video, please put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.